this is Ron from Math and today we're going to be doing number 23 from 1st and 2nd grade Math Kangaroo of 2019. At first glance, this problem might seem troublesome because of its high status on the test. It might scare some people, or people might not just get to it. But today, I'm going to be proving that this problem was more than easy, so no one could worry. So without further ado, let's get to solving this problem. Peter chose a square of 4 cells in the table, so that the sum of the 4 numbers inside the square are greater than 63. Which of the following numbers must be in the chosen square? And it shows the answer key for 14, 15, 17, 18, and 20. And it must be one of these to solve the problem. Now, to start the problem, we can look at the square. So let's just pick one out of the graph. Okay, so we got 1, 2, 6, and 7. Now, this is a cell, but it won't work. Now, you might think we would have to add it all up, but we can use a much simpler strategy. So, since there are 4 cells, we can multiply 4 by 7. Why? Because we can have 7 in all of these cells, which would equal 28. So we can eliminate it with it not being more than 63. Now, we're going to use this on a larger scale. So let's do this. 10 times 4. 10 plus 10 plus 10 plus 10. That would equal 40. So we can eliminate every number from 1 to 10. And there we go, we've already eliminated half the numbers. But from down here, it'll get a little bit more troublesome. But not that much troublesome, because this way will make it much more simpler. So, let's get on to some eliminating numbers. Okay, so we're going to be eliminating some of these numbers for 11, 12, 13, 14, 15, for the 6, 7, 8, and 9, 10. Because if you have a square that's above, like right here, let's say, we can use a strategy that we learned for 15 times 4 is equal to 60, which is still less than 63, so it wouldn't work. And now we can get on to doing these numbers. So this time it'll be a little bit more specific. For this one, 17 times 4 is more than 63, approximately 68, which is 5 more than 63. Now you might think it works. Wrong, because we still have 11, 12, and 16, 17, which won't work. Next, we have 12, 13, 18, and 17. Now we can just use simple addition to do this, and it will be less than 63 once you solve it. But now, we're going on to the 2 last things that we haven't eliminated. 13, 14, 18, 19, which is more than 63 as 64, and 14, 15, 19, 20 as 68. Now at this point we can use simple elimination to do it again. Okay, so the elimination, we can eliminate 15 and 20 and 13 and 18 because these are on the sidelines. The only numbers that we haven't eliminated after that, because 15, 20, 13, 18 are on the sidelines and can't share, is 14 and 19. Now let's just look at the answer choices again. We have 14, but we see no 19. So therefore, 14 is the answer for this. Now, whenever you see a problem such as this, you can use simple elimination and a pretty good strategy for, let's say, 4 cells and a number to eliminate the cell pods so you can get your answer. So with that, we have finished our problem.